Yes, thank you very much for the kind introduction. As has been said, the topic is integrating of generative AI into CAE workflows with simulation data management, and I, with that, try to actually reflect on the topic of how can AI actually help to design a vehicle or a product. Okay, first, I want to just remind about the 3 challenges that we have. The first is about using agentic AI. The second one is actually preparing the knowledge such that the AI is not hallucinating so much. And the third challenge is actually integrating AI for robustness assessment in the process of the daily workflow of the users. However, since challenge number 3 and challenge number 2 are the homework that we have to do in order to get a meaningful way of actually integrating agentic AI, I will go in my presentation from challenge 3 to challenge 1. And I'll try to highlight up here which of the challenges I think is addressed with the different topics in our SDM system. So first of all, just a very short notice, one slide about what SDM system actually in our mindset is. On the one hand, it has to deal a lot with model management, like creating lots of simulation models, their versions, integrating with the CE tools, the CE preprocessing tools, creating the processes of submitting the jobs to the HPC system. And then on the HPC system, typically there's also the part of extracting all the key results, the KPIs, the curves, the media, the videos, the pictures, whatever is needed to actually assess the results, and everything is actually imported then in a result database. And with respect to the V model, which was part of the challenge, there's also a third pillar in the SDM system, which deals with setting up the project, defining all the requirements, translating the requirements from the specifications into technical values, and then using these requirements and the thresholds that have been defined throughout the whole simulation data management process, so that you can see at every point during development how much of your requirements have actually been fulfilled or not. Okay, with that, because there are lots of slides, I'll come to the next thing, and this is actually about machine learning and AI on top of things that we have in the SDM system. So this is machine learning and AI where we learn from the actual simulation results. And as I said before, we have in our SDM system very many simulation results, and so it comes into mind that we should actually be able to use that to actually leverage with AI some additional knowledge. And this is something we are doing for quite some time right now in the SDM system already. So I just want to reflect very briefly on it. So one of the things that we have is, for example, an add-on where you can do data analysis with. Actually, this add-on was only meant as a demo add-on, an example, so we can show customer what they can implement in our SDM system. And it provides very easy means of doing data analysis. Things like scatter plots, a correlation matrix, trend analysis, nothing very fancy. But the key point here is, in order to do this data analysis, I do not have to run a campaign. I do not have to create additional simulation data. I can do that, but I can also just filter down and search for the data in the SDM system, and then I can use the add-on on top of it and do data analysis with the data which I already have. If it's sufficient or not is another question. And within such an add-on, you can also do some more sophisticated stuff, for example, using a TensorFlow regression model to actually train on the selected data in order to get a model such that you can try to explain the behavior of your physical system or your system using these kinds of techniques, where we have seen a lot on that topic throughout the last days. And as I said, this is only an add-on which was meant as an example. You can also create add-ons which connect, for example, with other tools, for example, AWS SageMaker or Microsoft Power BI or whatsoever, which can be used to actually create data analysis on top of your data. Another such add-on, and I think I'm sure that the presentation after mine will reflect on it a little bit more, is an add-on which was implemented by the company Seduct, and which is actually Familist. And with that, each simulation that comes into the SDM system is also put within the Familist database in such a form that whenever a new simulation comes in there, it can also scan automatically whether the behavior of each part is something very unusual that has never seen before in any of the other simulations which are in the Familist database. And these can be many thousands of simulations. And in case that the behavior is significantly different than what has been seen in previous simulation, it can raise an event, a kind of alert to the user and tell him, okay, you should look at that. And yeah, I highlighted up here the presentations where this has actually been presented already some time ago. And other than that, just two more examples of how to integrate processes into the SDM system. For example, here I have a presentation where we integrated reduced order models in such a way in the SDM system that it's seamless for the user. So each time he creates a simulation model, also the reduced order model was created, and then depending on the load case, different parts of the models were using the reduced order model or were using the full model. Or also the topic of predictive AI. In the last couple of months or year, we heard a lot about predictive AI, such as Sim AI. I think Thorsten Pohl also mentioned that in his talk. And predictive AI in the terms of an SDM system is just another solver. So actually, in terms of an SDM system, I don't care whether it's solved by a real solver, LS-DYNA, PEMCrash, whatsoever, or if it's solved by physics AI. And in this presentation, we showed how the process can actually work and can actually generate a real simulation result, which then can run through all the post-processing steps and produce the same kind of data which can be used in the SDM system as if it would have been a real solver run. And I'm pretty confident that the same could be done with other physics AI solvers. And even the training data can also be created within the SDM system, and even the training itself could be thought of as a process which can run in the SDM system, such as any other solver run. Okay. But with this, I'm coming to the other kind of AI, which got a lot of traction during the last years, and this is generative AI. And with me, I brought a couple of examples, what we have done during the recent years, to actually see which use cases could be beneficial for users. Most of the stuff I'm showing is going in the direction of challenge number 2, which is about how to integrate knowledge that I gather in the SDM system, or knowledge that I need for my AI to give grounded answers within the AI that we use in the CAE workflows. And then at the very end, I come why this may be important for agentic AI. Okay, so the very first thing that we did actually is we integrated AI with our user manual. So I think every CAE vendor has already done this, and it's becoming more and more useful actually, and it's not very difficult, to be honest. So we just put our manual into a rack system, so we chunk that data, we put it into a vector storage, and we are using retrieval techniques like rack, retrieval, augmented generation, to generate context where the AI then can create an answers. And as I said, this has, I think that's up running now for like 2 years maybe. And what we are working on right now is that we also will give the customers the opportunity to put their own documentation also in the SDM system and let that actually be ingested into the RAC system, such that they can not only ask about SCALE.sdm, but they can also ask about their internal modeling guidelines, about their internal scripts, their wiki pages, and if the tool or if the solver vendors allow it, maybe even the solver documentation and things like that. Or, yeah. And these RAC system can then be configured as LLM endpoints to actually serve other use cases. For example, in our SDM system, it's very typically that you go into the SDM system and you open the file directly in something like a text editor. It's surprisingly that the text editor is still a valid pre-processing tool for many CAE engineers. And in case of using Visual Studio Code, you could actually open Visual Studio Code, and with one of the many extensions that exist for Visual Studio Code to integrate AI, you could connect that to the LLM endpoint, which actually points to the RAC system. And then you can actually select, for example, tag a card, an Alice Steiner card, and ask, okay, what the heck do I see here? And probably the AI may give a more grounded answer than if you would have asked Claude or OpenAI without the knowledge of the manual. You can, of course, if the solver vendors have such things like ANSYS GPT, you could also integrate that LLM endpoint here at that point. And yeah, if other tools like Answer, Meta, or whatsoever will integrate this kind of interaction, that can also be used. Another thing, but that's also upcoming, is that the custom agent frameworks, and we saw that in the previous presentations as well, they can also access through an MCP server actually our SDM system then, and query additional data, download files, maybe in the future also changing files, triggering jobs, and so on. Okay, for now it's mostly read-only what we have there. Okay, but coming to the part of knowledge. So Rodrigo already showed that in his presentation where we worked with Sky on this research project, which is called SafeCar.ml. So in any simulation data management system, capturing what the user actually did is crucial. So you actually, in our system, we have many tools for that, like, for example, this rail graph, which shows which version depends on which, and also this text field where the user actually is requested to enter what they did. However, entering change documentation is, nobody is very keen of it, and nobody is actually doing it in a meaningful way, or they have to be forced to do that. And the consequence is bad change documentation. And that means even though you have SDM system in place, sometimes it's hard to find the data, to follow the sort, or to follow the reason how a change actually got into a solution. And the goal of this project, SafeCar.ml, was to do the homework and actually give the user tools at hand using AI such that they can provide better change documentation. And how does that work? So the user actually has a problem and needs to solve that. So he applies some change using his pre-processing tool of choice, and then he got a model which is changed with a change that he is requested actually to document in the SDM system. However, while the user is writing up some lazy comment, in the background the model compare, or maybe other tools, is running and extracting technical information, and also what we saw before with the vision models, trying to get a good description of the nature of the change. And all that information is put into a large prompt. The large prompt is actually used to create a concise summary of what has actually changed, so what is meaningful and what is not meaningful. And this actually helps the user. there is sometimes information which the AI cannot capture. For example, the reason of the change. And so what we also did is we use AI to flip the paradigm and let the AI check whether the user provided already the reason for the change. So we call that it's a check on the history comment. And if it doesn't, it will raise a question. Okay, please provide also the reason. So the AI is actually requesting data from the user in that case. And in the end, we hopefully get an enhanced change description. So now we have an enhanced change description on the one side of the thing. The other side is with result data. So what you see here is our web client for the result data. Each line is one simulation result. And actually, this can become hundreds of thousands of simulation records. And then the user can actually look at a report, which can be quite large, depending on the kind of simulation. And the user actually has here a field for writing down the summary of his observations. So what are the findings of the simulation? Did it actually solve the problem? Did I observe something weird? And so on. And also here, we already implemented kind of proof of concept where we use AI actually to go automatically through the lengthy report, compare it to the predecessor, and try to come up with some additional information for enhancing also the observation or hinting the user to things that he or she might not have seen. Okay, with all that data in place, what can we do then? The first thing is we can use that in the generic search that we have in the SDM system. So the user can actually enter a string, and then he can search for it and can find probably a similar problem. However, with AI, we also now can actually semantically search for that data. So we can actually ask a question in Spanish and get a change description by a user who entered it in Germany, and vice versa, or use different terms, or yeah, whatsoever. So it's like the research feature in ChatGPT and things like that. So with that, you can already find old data where maybe similar problems occurred, where you did similar changes and stuff like that. But there's still one piece to the puzzle missing. And this is something, yeah, I have to admit, where we just started working on, and which also Rodrigo mentioned in his talk, and it has to do with knowledge graphs, actually putting the data that we have in the SDM system into an ontology and into a knowledge graph to solve this kind of problem. So whenever a user comes and says, okay, I have here a problem, how has that solved in the past or by someone else? And then with the retrieval, which I mentioned earlier, which was the page before, the AI can actually probably, hopefully, find candidates where a similar problem occurred. And from there, you can do context expansion using the knowledge graph to go along the trace and try to find out, was there already a solution to this problem? And then you can go the knowledge graph into the other dimension and see, okay, what changes did lead to the solution. But you see, in order for actually having then meaningful like documentation, I need to do my homework before and try to increase the quality of the actual change documentation and observation documentation. And then hopefully, I can actually provide a concise solution to the user. Okay, so far to challenge number 2, to the knowledge. And now, the user in the future could not only be a human being, but it could also be an agent to actually access this data. So on our journey to incorporating agents, we are very at the beginning. So what I bring here is an AI agent which we are currently implementing, or the first use case which we are implementing on top of the AI agent framework in our system. And this is for analyzing the failure of jobs. So the most common case is the user started a job in the SDM system and it fails for some reason. And the user doesn't know why it failed. So he or she would just go in here and ask the question, why did it fail? And then the agent actually runs through all the files of the simulation, tries to figure out what went wrong, and also is requesting data from the rec system, for example, of the company documentation, of the LS Dyna manuals, maybe ANSYS GPT, and getting answers of how to fix that maybe. And in the end, it should also be able to actually query the rec system of the SDM system, whether there was a user which already fixed that problem, and it could be as easy as changing the version of a certain script, putting a certain group in, or whatsoever. So this is actually something that we are going to develop right now, and which gives an outlook. Okay, with this, I'm almost at the end of my presentation. With SCALE.sdm, you can operate that on cloud or on-premise. And now with the agentic services, we also provide a proxy for any kind of LLM models which can be locally hosted models or models hosted outside in the cloud by any of the AI providers, or even specialized models like ANSYS GPT. And our own infrastructure, like desktop client or web client, they can access all this AI infrastructure to actually implement the different load cases that I've shown today. Okay, with this, SDM, we hope, becomes a central hub for connecting all the simulation workflows and also integrating AI. And with this, I'm at the end of my presentation. Thank you very much.
Okay. Yeah, many thanks for that interesting presentation. At first, questions from the audience. As usual. Okay. Maybe. Sorry.
So thank you for the great presentation, and thank you for mentioning a lot of the concepts I will talk about as well. On the knowledge graph things and the ontologies to be built, what is your process of building ontologies, mixing manual and automated processes?
Actually, in our SDM system, the data is already stored in a way which is very structured. So what we need to do is describe our data model in terms of an ontology. And then we can actually use that for querying the knowledge graph. And we will use, we are using a graph database, and where we can then using the ontology to query against the graph database. We are also planning the AI to actually create the queries for the ontology so that it can actually depending on the situation, create a meaningful query for retrieving this or that information. But as I said, this is all still a little bit research also to do for us.
Okay, yeah, thank you.
Okay. Time for one more question. Yes, please. Come to the microphone.
So from what I'm understanding, what you're using the LLM for is to make sure that you can populate the data in your graph database and in your vector store, right? So which means that I think it makes a lot of sense here that you don't go for the expensive models like ChatGPT or anything like that, like the more expensive models, but rather something that is more local and cheap and not very big, because that way the inference can be very fast, first of all, and then it's also going to be very cheap, as at the end of the day, all you're doing is putting the data in the latent space and in the graph, right?
Yeah, you're right. As much more context you put into or giving the LLM, you can use cheaper models as well. But to be honest, just for being lazy, I prefer the good models just for now, if we can afford them. What we're using here mostly is GPT 5.4 and also Claude Opus models, which may be a little bit big, but they're giving the best result until now.
Fair enough. Okay.
Okay. Many thanks for the nice presentation.